Good morning, everyone. Can you all hear me here? Okay. So first of all, I'd like to thank the organizers for joining the HotCloud and Hot Storage sessions. And I'm really excited that we get to share this discussion with audience from both workshops. Okay. So we have seen charts like this a lot these days, which shows that the total volume of digital information has been growing fast in the past few years and is projected to grow even faster in the future. One thing notable here is that people have found out 70%, 75% of that total data actually belongs to personal data. We ourselves generate a lot of that. Okay. Another trend is that compared to before, we are no longer tied to our computers or even laptops when we access the data. According to a recent report from Cisco, the total volume of mobile traffic has grown by 81% just from 2012 to 2013. And this number is projected to grow by 11 times by 2018. And where and how do we store all those personal data collection? Things have changed a lot regarding personal data storage in the past several decades. And kids today may not even recognize some of the items we show here. Okay? Either internal or external, these traditional storage options share one thing in common. You have to possess either both the storage device and the storage media at time of access. Either you have it already inside your computer or you have to plug it in. Change is more drastic in the past few years. Remember how life suddenly became easier when we have these things coming out. And then just 10 years later, the frustration we had when we suddenly need to find an old file, and then there are 30 of these cute things lying around, plus 5 more that should have but won't. And these days, we suffer less from that kind of scenario because we have these new things, right? And for them, the good thing is our personal data is now detached from personal storage device or media, personal storage hardware. Let me first do a quick poll here. How many of you have used some form of cloud storage, including but not limited to these popular choices? Raise your hand. So indeed, it's popular because it's wonderful. It allows us to access data wherever we can as long as there is internet, and oftentimes even when there is no internet. And we have trouble-free storage. We don't have to worry about buying and owning hardware. And we can keep our stuff finally all together. Okay? But however, here comes the second question. How many of you have entirely ditched all those traditional external storage choices I listed in the former slide, or third-party backup, and totally transfer to a single cloud provider as your primary data repository? How many? Not surprised. They are not fully utilized, mainly, I guess, for 2 reasons. First, cloud storage is still very expensive. And second, they don't provide you with any guarantee when there is data loss or corruption. As a brief survey, we looked at 7 popular cloud storage providers. Okay? And the pricing varies, but in general, you have to pay somewhere between $60 to $200 per 100 gigabyte per year. In comparison, these days you can get 3 terabytes of external storage for the same price, okay, for $100. And such a drive typically lasts for more than a year. Okay? And regarding guarantee, we also looked at all the fine prints regarding data availability. And they pretty much all include the same clause. These services are meant to be as is or best effort. That means provider will make reasonable effort toward avoiding data loss. But they have no liability if that happens to the fullest extent permitted by law. So if you put your great-grandma's only copy of picture there and it gets lost, tough luck. And to their credit, actually Dropbox and Baidu Cloud are the only two providers that actually even mention about monetary compensation if the worst happens. And the compensation amount is at the level of several months service charge to be bounded by something like $20. Okay. And to take a closer look, we examine Amazon S3 storage, as it is actually the only provider that gives explicit guarantee on data availability. That is no guarantee toward data loss, but they say, okay, annually we guarantee availability rate. For example, the standard S3 provides 11/9 of object availability. That translates into an annual object loss rate of 0.000000001. Okay? There is also a reduced redundancy option, which corresponds to 4/9 of availability at about 20 cents per gigabytes per year, cheaper. So from that, we can probably infer that cloud storage providers are being conservative in both ways. On one hand, by default, they are replicating things like crazy. They replicate, georeplicate, and then replicate some more. Because if you lose data, that is going to make bad news story, and that is only good for your 6 competitors or more. And then the search costs of creating and then maintaining all these copies can be are of course folded in the service charge. On the other hand, still, there is no promise against data loss or corruption. Do things have to stay that way? If we look beyond our relatively new industry, people have long trusted strangers with our valuable belongings, like shipping, right? For more than once, I have gone to places like FedEx and let them ship my passport, okay? For visa application, for example, before a conference trip. What happens if it gets lost or damaged on its way? We know that is very unlikely to happen, but certainly not impossible. What do we do for risk management in this case? We buy insurance, right? We put a price tag to our passport to compensate for any booked travel, to the time and the money that we need for getting a new passport, plus some more to comfort our broken heart. Can we do the same for data storage? Okay. First thing in risk management is to assess potential hazards that may lead to loss, both from the customers and the provider's perspective. And for us, the most important category is the physical hazards that actually lead to data loss. Okay, the foremost one is actually storage hardware failures, in particular disk failures in our case. That is followed by security attacks and incorrect handling of data from human errors or software bugs. We can also have environmental damage, like building corruption or fire caused by accidents or wars. And finally, we have natural disasters like earthquake or flood. Okay. And beyond that, for providers, we may have false claims, insurance fraud from customers who claim that their data is lost when actually it's not. Okay? That is labeled as a moral hazard in insurance terms. And finally, for customers, when we entrust our data to a storage company, we expect the data to be kept there safe for a long time. This is different than the shipping case. In that case, if an item is delivered, the relationship is over. Okay? What if a company goes out of business? Okay? So we'll come back to that 2 later categories of hazards at the end of the talk, but first we'll focus on the more prevalent physical hazards that lead to true data loss. Okay? And for them, we already know how to reduce the risk to increase redundancy. Okay? That brings us unique advantages for data insurance providers. Okay? They can easily make extra copies for the data and then actively reduce the risk rather than just managing risk. For example, by making extra copies, the provider can lower the risk exponentially for data damage or loss, while a health insurance company won't be able to make copies of our body parts. And following that thought, we can think of data storage providers. They actually have total control over our data, while health insurance companies have about no control, zero control over how we eat or whether we exercise. And then for data, any copy is as good as original. And shipping companies won't be able to say that for our personal items. And finally, to make an extra copy of the data, it takes much, much lower cost compared to typically the acclaimed value of the data. And while for things like cars or houses, their true value is typically considered actually the cost of replacement itself. Okay? So what that means is that for a lot of storage companies, considering how aggressively they are already making copies of data, rather than adding more replication to ensure data, they can get to reduce the redundancy level for the default data, for their baseline redundancy. So instead of providing 11 nines of data availability, what about lowering it to 4 nines or even 2 nines? Okay? So one thing notable here is that insurance, like in the case of shipping, should be optional to users, while lowered baseline redundancy should help lower the cost for all users. One thing that could do is by making storage in the cloud more affordable, we can attract more paying users. I'm not going to do a third poll here, but I suspect, just like me, many of you are freeloaders who stay within the 5 gigabyte or 2 gigabyte storage space. And actually, even though there is no formal report, according to online discussions, among all Dropbox users, for example, only 4% are paying members. That is actually another major factor contributing to the high cost of cloud storage. Okay? So this is how we picture things might work when we add data insurance into cloud storage. Okay? Suppose this is my Dropbox hierarchy, my directory tree, because people still like to organize things in a hierarchical way. Okay? It is rather impractical for us to declare the value of individual files, but it might be much more reasonable so if we declare at the directory level. For example, I may put on the value, declare a value of $1,000 per megabyte for all my photos, but then my baby subdirectory is considered more precious. Although in this case, considering how consistently US hospitals dress our babies, it might be much easier for Dropbox to get away by sneaking in another baby's picture. I wouldn't know. But you get the idea. Okay? Tax files, bank statements, okay? If they get lost, I probably can recover from banks or the government, although it will be time-consuming and annoying. So still valuable, but not irreplaceable. Finally, work, okay? Things like paper drafts may be accessed a lot, and there might be tons of copies existing in my active laptops, as well as my students. So who cares? Okay. Then we come back to that interesting moral hazard. What if somebody claims his or her data is lost in the cloud where it's not? Okay? In that case, the burden of proof lies on the customer, him or herself. Remember that when we go shipping, we get a receipt, right, which may carry insurance information. And if we buy data insurance, we should also receive and hold on to a data receipt that contains the normal metadata, for example, date and data size. In addition, there should be one or two hash values for each data block, okay? That shows what your data actually is. Note that common hash algorithms like MD5 or SHA-2 are not collision-free, but it is computational impractical for us to do a pre-image attack. That means given a certain hash value, it is very, very difficult to produce a fake cache of data block that actually gives you the same hash. And this challenge can be compounded by using two or more hash values. So we should have a receipt like this. Therefore, it is actually easy for cloud storage providers to check whether a certain data loss claim is valid. If I can give you data blocks that generate the same hash value, it's your original data. Okay? And then next, we come to assessing how much data insurance will cost us. Okay? For traditional industry categories like health insurance or property, the premium paid by many, many individuals are pulled together to cover three things: the expected loss, considering the probability and consequence of loss, and the underwriting expense, the cost of coming up with these policies and plans, doing risk assessment, and finally, the profit of insurance itself. For a ballpark assessment here, I'll casually throw away the last two terms. Okay? So therefore, we have to balance the income, the left hand, which is still the premiums, and then the expense, the right-hand side. That is made up by two terms. Okay? First, the cost of making extra copies. Okay? And the second, the indemnification. The second, the item of making extra copies help us reduce the probability of data loss. And if the worst happens, we will need to pay the customers at their acclaimed value. So here, F base is the baseline availability. That is the annual object loss rate corresponding to the 4 nines, 9 nines, etc. Okay? And F is the annual disk failure ratio, okay, aggressively assessed to be 0.1 according to a Google paper published in FAST 2007. R is the replication degree, okay, how many extra copies do we make. V is the declared data value in terms of dollar per megabyte, and the C disk is also the disk price, also in dollars per megabyte, and set to $100 per 2 terabytes according to current market, pessimistically. Okay. So here we have some sample results in the case where declared value is $10,000 per megabyte. Okay. So first, we check the case where we have a baseline redundancy of 0.1. That corresponds to 1/9, which is the bare minimum of cloud storage. You only store one copy in the cloud. The x-axis shows the number of extra copies from 1 to 3. The y-axis shows in log scale the annual premium you have to pay per megabyte. Okay? So we can see as we grow R, the amount decreases. Okay? And what if we have the baseline redundancy that gives us 3 nines? Okay? Then you cut the premium by 100 times, actually. So with 3 copies and baseline redundancy of 3 nines, you get the premium of 0.01, that is 1 cent per megabyte per year, which translates into $10 per gigabyte per year. Does that still sound like a lot? We have to look at PV value, which is the ratio between premium to the claimed value. Okay? And what do we accept for shipping? Actually, that is equivalent to the highest number we show here, with 0.1 baseline redundancy and only 1 extra copy. Okay? So here is what we pay for USPS. We have to pay $125 to insure an item at $10,000. And we pay $90 to both UPS and FedEx. Okay? The premium declines when we grow either R or F base, and it is obviously more desirable to keep F base low and R high. This way we get to lower everybody's storage cost. And finally, in these numbers, the indemnification term dominates, and that is true until we raise R or the baseline availability to a very high level. Okay? Several random thoughts related. First of all, what about we have the cloud service discontinued? It definitely helps if we can keep our stuff all in the same place. Okay? But here, we may also borrow existing practice from a quite mature insurance industry. For example, cloud providers who double as insurance carriers in this case may sell the insurance to third-party underwriters in the form of reinsurance. Okay? And we might be able to do access pattern optimizations. We have no proof here, but intuition is that precious data tend to be hot data, cold data rather than hot data. So maybe it makes sense to store them in cheap, low performance, but very reliable media. And finally, we may want to go beyond personal data for insurance, although it is much more complicated for business data and to assess the implication of data loss or damage. But then, again, existing practice in business risk management can be applied here. To close, we argue that data insurance might be a solution to make cloud storage cheaper or at least appear so, safer or at least appear so, and simultaneously cheaper. Okay? It provides peace of mind to customers and also help providers to reduce their baseline redundancy. Considering that how aggressively these providers have already been making replicas, we think that the implication of adding data insurance is actually doing subtraction rather than addition here. By telling storage providers what data are important, we as users actually implicitly disclose what data are not. And that is perhaps a more important piece of information. And finally, if we think this idea is worth of further investigation, it will be helpful to do interdisciplinary research that spans computer science and engineering, marketing and risk management, and legislation. That is all. Thank you.
Thank you. It's a very good talk. Are there any questions?
Sure, I'll ask a question. Emil Refus on Reykjavik University. First, a comment. It's a very nice talk. One just technical tidbit. You can actually adapt the hashing scheme based on the size of the insurance that's being used. So if there's a huge insurance claim being made on a particular piece of data, you could simply have 3 or 4 or 5 hash functions, something according. My bigger question is that I don't know if other people are like me, but I have no organizational skills. I can't really have like a tree of important things on my disk. I simply can't. I don't even know what's on my laptop right now. Am I really able to figure out what data is important to me at this stage? Can I do the risk analysis ahead of time with this much detail?
Yeah, that is a very good question. Actually, that's one question mentioned by more than one reviewers. Just like when we go to shipping, how much is my passport worth? We probably would just do $3,000, $5,000. That's a gut feeling. How do we do this assessment accurately is a hard thing. So to help assess data value perhaps deserves the whole study by itself.
Mike Kozic from Intel. I was curious if you'd thought about correlated failures, in particular the system administrator attack. So one of the things that's interesting about insuring packages with UPS, right, is you could have a plane accident or something where you lose many packages. Mm-hmm. Here you could lose sort of everything globally.
Yeah, that is possible, but given the scheme already implemented by, I guess, cloud providers in doing geo replication and all other things. For example, one of the companies actually have their backup, like all the changes you made in the past months is actually saved, in version systems, etc. So that may help kind of diversify the people involved and lower the probability of one person's error may cause a very large damage. Yeah, thank you.
Quick question. Who saves all the hashes for me?
Who saved the hashes for you?
Do I need my 11.9's reliability to save all my hashes, or do I just keep a whole bunch of receipts
That's
in my
a good
back
question.
pocket?
Yeah, maybe in your pocket. Yeah, that's a very good question. But I think that maybe that's something small enough. Where do we save? One very nice thing here is that for cloud storage, we enjoy the benefit of putting everything together so that we don't have to search 3 places. But just like the previous talk mentioned, to have all your things in one place may have grave consequence. Okay. Thank you again.
Okay, let's thank the speaker.